Yo, how's it going? How's everybody doing? Let's take a look at this Nvidia CEO meeting. Let's go, brother. I know somebody just had a whole speech. Oh, we're still waiting. Oh, okay. Okay, well, just so we won't. Like, I'm not sure how the monetization is going to work on that, so it may mute the whole video depending on Twitch or demonetize it on YouTube. So we're just going to mute that for a second while we wait on, you know, the CEO to come out. I don't know what Jensen is doing, but, you know, it is what it is. Probably trying to find another leather jacket. You know how it goes. So we're just trying to wait and see exactly what happens with them. Hopefully it comes out and it actually shows it. I'm a little worried, though, right? Because we're talking about like the 5090, 5080, 5070. I remember when I did the video for the 4090, 4080, and 4070, and I was worried about the price point then, too. And plus, the cards were so big, man. I hope the newer cards are a little bit smaller, just because, like, having to buy a brand new case just for a 5090, actually, you know what? Oh, you know what? It just switched to it. Never mind. Okay, yeah, so having to buy a brand new case for a 5090 is just a bit much for me. So let's see. Hopefully it's better this time. Hopefully it's not like a 3-slot card or a 3.5 slot card.
Is how intelligence is made.
Let's find out.
A new kind of factory. Generator of tokens. The building blocks of AI. Tokens have opened a new frontier, the first step into an extraordinary world, where endless possibilities are born. Tokens transform words into knowledge and breathe life into images. They turn ideas into videos and help us safely navigate any environment. Tokens teach robots to move like the masters.
Masters?
Inspire new ways to celebrate our victories.
A martini, please.
Something light up.
Thank you, Adam.
My name is Samuel.
When we need it most.
Hi, Maroka.
Hi, Anna. It's good to see you again.
Hi, Emma. We're gonna take your blood sample today, okay?
Don't worry. I'm gonna be here the whole time.
Nah, I'm good.
They bring meaning
No,
to
thank
numbers. To help us better understand.
Girl, you better
the world
run.
around us.
Hard pass, bro.
Predict the dangers that surround us. And find cures for the threats within us. Tokens can bring our visions to life.
Is that an Apple? A Vision? Is that what it's called? Apple Vision?
And restore what we've lost.
These machines are awesome. I've seen these work before.
I got my voice back, buddy.
They help us move forward. One small step at a time. And one giant leap. Together. And here is where it all begins.
Oh, look at that lens. 200 to
Welcome
400.
to the stage, Nvidia founder and CEO, Jensen Huang.
What? What? See? Trying to get that leather jacket going.
Welcome to see
Ooh, that one's fancy. He got that from a shiny alligator,
excited to be in Las
not just a
Vegas?
regular alligator.
Do you like my jacket?
Yes. It's pretty sick.
I thought I'd go the other way from Gary Shapiro.
Who?
I'm in Las Vegas after all. If this doesn't work out, if all of you object, Well, just get used to it. I really think you have to let this sink in. In another hour or so, you're going to feel good about it.
Come on, I already made fun of it. Let's go.
Well, welcome to NVIDIA. In fact, you're inside NVIDIA's digital twin. And we're going to take you to NVIDIA. Ladies and gentlemen, welcome to NVIDIA.
Oh, we're going to do NVIDIA. Hold on, let me find my phone. Let me change the background.
You're inside our digital twin. Everything here is generated by AI. It has been an extraordinary journey, extraordinary year, and it started in 1993.
Ready, go!
Yo.
With NV1, we wanted to build computers that can do things that normal computers couldn't. And NV1 made it possible to have a game console in your PC. Our programming architecture was called UDA, missing the letter C until a little while later, but UDA, Unified Device Architecture. And the first developer for UDA and the first application that ever worked on UDA was Sega's Virtual Fighter. 6 years later, we invented, in 1999, the programmable GPU. And it started 20 plus years of incredible advance in this incredible processor called the GPU. It made modern computer graphics possible. And now, 30 years later, Sega's Virtual Fighter is completely cinematic. This is the new Virtual Fighter project that's coming. I just can't wait. Absolutely incredible. 6 years after that, 6 years after 1999, we invented CUDA so that we could explain or express the programmability of our GPUs to a rich set of algorithms that could benefit from it. CUDA initially was difficult to explain, and it took years, in fact. It took approximately 6 years. Somehow, 6 years later or so, 2012, Alex Karshevsky, Ilya Sutskever, and Jeff Hinton discovered CUDA, used it to process AlexNet, and the rest of it is history. AI has been advancing at an incredible pace since. Started with perception AI. We now can understand images and words and sounds. To generative AI, we can generate images and text and sounds. And now, agentic AI. AIs that can perceive, reason, plan, and act. And then the next phase, some of which we'll talk about tonight, physical AI, 2012. Now, magically, 2018, something happened that was pretty incredible. Google's Transformer was released as BERT, and the world of AI really took off. Transformers, as you know, completely changed the landscape for artificial intelligence. In fact, it completely changed the landscape for computing altogether. We recognized properly that AI was not just a new application with a new business opportunity, but AI, more importantly, machine learning enabled by transformers, was going to fundamentally change how computing works. And today, computing is revolutionized in every single layer, from hand coding, instructions that run on CPUs to create software tools that humans use. We now have machine learning that creates and optimizes neural networks that processes on GPUs and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation in just 12 years. Well, we can now understand information of just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, We can understand amino acids. We can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see out there, what modality is the input that it learned from? What modality of information did it translate to? And what modality of information is it generating? If you ask these three fundamental questions, just about every single application could be inferred. And so when you see application after applications that are AI-driven, AI-native, at the core of it, this fundamental concept is there. Machine learning has changed how every application is going to be built, how computing will be done, and the possibilities beyond. Well, GPUs, GeForce, in a lot of ways, all of this with AI is the house that GeForce built. GeForce enabled AI to reach the masses. And now, AI is coming home to GeForce. There are so many things that you can't do without AI. Let me show you some of it now.
In the medical field, they always use Quadro. Is that a lizard?
That was real-time computer graphics. No computer graphics researcher, no computer scientist would have told you that it is possible for us to ray trace every single pixel at this point. Ray tracing is a simulation of light. The amount of geometry that you saw was absolutely insane. It would have been impossible without artificial intelligence. There are two fundamental things that we did. We used, of course, programmable shading and ray traced acceleration to produce incredibly beautiful pixels. But then we have artificial intelligence be conditioned, be controlled by that pixel to generate a whole bunch of other pixels. Not only is it able to generate other pixels spatially, because it's aware of what the colors should be, it has been trained on a supercomputer back in Nvidia, and so the neural network that's running on the GPU can infer and predict the pixels that we did not render. Not only can we do that, it's called DLSS, the latest generation of DLSS also generates beyond frames. It can predict the future, generating 3 additional frames for every frame that we calculate. What you saw, if we just said 4 frames of what you saw, because we're going to render 1 frame and generate 3, if I said 4 frames at full HD, 4K, that's 33 million pixels or so. Out of that 33 million pixels, we computed only 2. It is an absolute miracle that we can computationally using programmable shaders and our ray tracing engine, to compute 2 million pixels and have AI predict all of the other 33.
He meant 4K.
And as a result, we're able to render at incredibly high performance because AI does a lot less computation. It takes, of course, an enormous amount of training to produce that, but once you train it, the generation is extremely efficient. So this is one of the incredible capabilities of artificial intelligence, and that's why there's so many amazing things that are happening. We used GeForce to enable artificial intelligence, and now artificial intelligence is revolutionizing GeForce. Everyone, today we're announcing our next generation, the RTX Blackwell family. Let's take a look.
Oh, let's go. He said full HD and then he said 4K. I was like, bro, what are you talking about? But then he said 2 million pixels, so that would be 4K, so UHD. Please be small. Just be small. I have one ask. I don't want to have to buy a new case. That's my ask. That doesn't look like
Here
the 5090.
it is. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders, one is for floating point, one is for integer. G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is the brand new RTX Blackwell 5090.
That's the 5090?
Now,
it's a 2-slot.
Even the mechanical design is a miracle. Look at this, it's got 2 fans. This whole graphics card is just one giant fan. You know, so the question is, where's the graphics card? It's literally this big. The voltage regulator design is state-of-the-art, incredible design.
So has
did a great job.
The 12 pin.
Here it is. Thank you.
That's the 5090?
Okay, so those are the speeds and feeds, so how does it compare? Well, this is RTX 4090. I know many of you have one. I know it. Look, it's $1,599. It is one of the best investments you could possibly make. For $1,599, you bring it home to your $10,000 PC entertainment command center. Isn't that right?
No.
Don't tell me that's not true. Don't be ashamed. It's liquid cooled.
No.
Fancy lights all over it.
Yes.
You lock it when you leave. It's the modern home theater. It makes perfect sense. And now for $1,599, you get to upgrade that and turbocharge the living daylights out of it. Well, now with the Blackwell family, RTX 5070, 4090 performance at 549.
I'm offended. Somebody owes me $1,000.
Impossible without artificial intelligence. Impossible without the 4 teraops of AI tensor cores. Impossible without the G7 memories. Okay, so 5070, 4090 performance, $549, and here's the whole family. Starting from 5070 all the way up to 5090. 5090, twice the performance of a 4090. Starting, of course, we're producing at very large scale, availability starting January. Well, it is incredible, but we managed to put these in gigantic performance GPUs into a laptop. This is a 5070 laptop. For $1299, this 5070 laptop has a 4090 performance. I think there's one here somewhere.
Please take laptops with a grain of salt.
This.
Look
at this thing.
It has to do with the power output. So if the power output is reduced, a 4090 may not perform as a 4090. So please bear that in mind.
Gentlemen, Janine Paul. So can you imagine? You get this incredible graphics card here, Blackwell. We're going to shrink it and put it in there. Does that make any sense? Well, you can't do that without artificial intelligence. And the reason for that is because we're generating most of the pixels using our tensor cores. So we ray trace only the pixels we need, and we generate using artificial intelligence all of the other pixels we have. As a result, the energy efficiency is just off the charts. The future of computer graphics is neural rendering, the fusion of artificial intelligence and computer graphics. And what's really amazing is, oh, here we go. Thank you. This is a surprisingly kinetic keynote. And what's really amazing is the family of GPUs we're going to put in here. And so the 5090 will fit into a laptop, a thin laptop. That last laptop was 14.9 millimeters. You got a 5080, 5070 Ti, and 5070. Okay, so ladies and gentlemen, the RTX Blackwell family. Well, GeForce brought AI to the world, democratized AI. Now AI has come back and revolutionized GeForce. Let's talk about artificial intelligence. Let's go to somewhere else at Nvidia. This is literally our office. This is literally Nvidia's headquarters. Okay, so let's talk about AI. The industry is chasing and racing to scale artificial intelligence. And the scaling law is a powerful model. It's an empirical law that has been observed and demonstrated by researchers and industry over several generations. And the scaling law says that the more data you have, the training data that you have, the larger model that you have, and the more compute that you apply to it, therefore, the more effective or the more capable your model will become. And so the scaling law continues. What's really amazing is that now we're moving towards, of course, and the internet is producing about twice the amount of data every single year as it did last year. I think in the next couple of years humanity will produce more data than all of humanity has ever produced since the beginning. And so we're still producing a gigantic amount of data, and it's becoming multimodal. Video and images and sound, all of that data could be used to train the fundamental knowledge, the foundational knowledge of an AI. But there are, in fact, 2 other scaling laws that has now emerged. And it's somewhat intuitive. The second scaling law is post-training scaling law. Post-training scaling law uses techniques like reinforcement learning, human feedback. Basically, the AI produces and generates answers based on a human query. The human then, of course, gives a feedback. It's much more complicated than that, but that reinforcement learning system with a fair number of very high-quality prompts causes the AI to refine its skills. It could fine-tune its skills for particular domains. It could be better at solving math problems, better at reasoning, so on and so forth. And so it's essentially like having a mentor or having a coach give you feedback after you're done going to school. And so you get tests, you get feedback, you improve yourself. We also have reinforcement learning AI feedback, and we have synthetic data generation. These techniques are rather akin to, if you will, self-practice. You know the answer to a particular problem, and you continue to try it until you get it right. And so an AI could be presented with a very complicated and a difficult problem that is verifiable functionally, and it has an answer that we understand, maybe proving a theorem, maybe solving a geometry problem. And so these problems would cause the AI to produce answers, and using reinforcement learning, it would learn how to improve itself. That's called post-training. Post-training requires an enormous amount of computation, but the end result produces incredible models. We now have a third scaling law, and this third scaling law has to do with what's called test time scaling. Test time scaling is basically when you're being used. When you're using the AI has the ability to now apply a different resource allocation. Instead of improving its parameters, now it's focused on deciding how much computation to use to produce the answers it wants to produce. Reasoning is a way of thinking about this. Long thinking is a way to think about this. Instead of a direct inference or one-shot answer, you might reason about it. You might break down the problem into multiple steps. You might generate multiple ideas and evaluate, your AI system would evaluate which one of the ideas that you generated was the best one. Maybe it solves the problem step by step, so on and so forth. And so now test time scaling has proven to be incredibly effective. You're watching this sequence of technology and all of these scaling laws emerge as we see incredible achievements from ChatGPT to O1 to O3, and now Gemini Pro. All of these systems are going through this journey step by step by step of pre-training to post-training to test time scaling. Well, the amount of computation that we need, of course, is incredible. And we would like, in fact, that society has the ability to scale the amount of computation to produce more and more novel and better intelligence. Intelligence, of course, is the most valuable asset that we have, and it can be applied to solve a lot of very challenging problems. And so, scaling law. It's driving enormous demand for Nvidia computing. It's driving an enormous demand for this incredible chip we call Blackwell. Let's take a look at Blackwell. Well, Blackwell is in full production. It is incredible what it looks like. So first of all, there's every single cloud service provider now have systems up and running. We have systems here from about 15 computer makers. It's being made about 200 different SKUs, 200 different configurations. They're liquid-cooled, air-cooled, x86, NVIDIA Grace CPU versions, NVLink 36 by 2, NVLink 72 by 1, whole bunch of different types of systems so that we can accommodate just about every single data center in the world. Well, these systems are being currently manufactured in some 45 factories. It tells you how pervasive artificial intelligence is and how much the industry is jumping onto artificial intelligence in this new computing model. Well, the reason why we're driving it so hard is because we need a lot more computation. And it's very clear that Janine?
Janine, where you at, girl?
it's hard to tell. You don't ever want to reach your hands into a dark place. Amazing. Is this a good idea?
You don't know what I like doing in my pastime, sir. Oh, snap, he has a Captain America shield. Knew it! I don't know, man. You saw what Thor did to his shield.
Wait for it.
Bro, your knee said no.
I thought I was worthy. Apparently, Yonir didn't think I was worthy.
The handle is the PC handle or
All
the
right.
case handle.
This is my show and tell. This is a show and tell. So, this NVLink system, this right here, this NVLink system, this is GB200 NVLink 72. It is 1.5 tons, 600,000 parts,
Full rack.
approximately equal to 20 cars, 120 kilowatts. It has a spine behind it that connects all of these GPU together, 2 miles of copper cable, 5,000 cables. This is being manufactured in 45 factories around the world. We build them, we liquid cool them, we test them, we disassemble them, ship them in parts to the data centers because it's 1.5 tons. We reassemble it outside the data centers and install them. The manufacturing is insane.
That's
But
crazy.
the goal of all of this is because the scaling laws are driving computing so hard that this level of computation, Blackwell over our last generation, improves the performance per watt by a factor of 4. Performance per watt by a factor of 4, performance per dollar by a factor of 3. That basically says that in one generation, we reduce the cost of training these models by a factor of 3. Or if you want to increase the size of your model by a factor of 3, it's about the same cost. But the important thing is this. These are generating tokens that are being used by all of us when we use ChatGPT or when we use Gemini, use our phones in the future. Just about all of these applications are going to be consuming these AI tokens. And these AI tokens are being generated by these systems. And every single data center is limited by power. And so if the perf per watt of Blackwell is 4 times our last generation, then the revenue that could be generated, the amount of business that can be generated in the data center is increased by a factor of 4. And so these AI factory systems really are factories today. Now the goal of all of this is so that we can create one giant chip. The amount of computation we need is really quite incredible. And this is basically one giant chip. If we would have had to build a chip, here we go.
While he's doing that, what's interesting about that server rack, it's very rare to actually see a server rack in liquid cooling. Like, it never happens. Generally, it's using fans, and you need a ton of cooling in your server room in order to actually be able to cool it. So the fact that he actually has a giant server rack of GPUs and they are all liquid cool speaks volumes. You never, ever, ever, ever see it. Because to fix something like that, if something were to go wrong, is super expensive.
The world's largest supercomputer, fastest supercomputer, only recently, this entire room supercomputer only recently achieved an exaflop plus. This is 1.4 exaflops of AI floating point performance. It has 14 terabytes of memory, but here's the amazing thing. The memory bandwidth is 1.2 petabytes per second. That's basically the entire internet traffic that's happening right now. The entire world's internet traffic is being processed across these chips, okay? And we have 130 trillion transistors in total, 2,592 CPU cores, whole bunch of networking. And so these, I wish I could do this. I don't think I will. So these are the Blackwells. These are our ConnectX networking chips. These are the NVLink, and we're trying to pretend about the NVLink spine, but that's not possible, okay? And these are all of the HBM memories, 14 terabytes of HBM memory. This is what we're trying to do, and this is the miracle. This is the miracle of the Blackwell system. The Blackwell dies right here. It is the largest single chip the world's ever made. But yet, the miracle is really, in addition to that, this is the Grace Blackwell system. Well, the goal of all of this, of course, is so that we can, thank you, thanks. Boy, is there a chair I could sit down for a second? Can I have a Michelob Ultra? How is it possible that we're in the Michelob Ultra Stadium? It's like coming to Nvidia and we don't have a GPU for you. So we need an enormous amount of computation because we want to train larger and larger models. And these inferences used to be one inference, but in the future, the AI is going to be talking to itself. It's going to be thinking. It's going to be internally reflecting, processing. So today, when the tokens are being generated at you, so long as it's coming out at 20 or 30 tokens per second, it's basically as fast as anybody can read. However, in the future, and right now with GPT-01, you know, with the new Gemini Pro and the new the 01, 03 models, they're talking to themselves, reflecting, they're thinking. And so, as you can imagine, the rate at which the tokens could be ingested is incredibly high. And so we need the token rates, the token generation rates, to go way up. And we also have to drive the cost way down simultaneously so that the quality of service can be extraordinary, the cost to customers can continue to be low, and AI will continue to scale. And so that's the fundamental purpose, the reason why we created NVLink. Well, one of the most important things that's happening in the world of enterprise is agentic AI. Agentic AI basically is a perfect example of test time scaling. AI is a system of models. Some of it is understanding, interacting with the customer, interacting with the user. Some of it is maybe retrieving information from storage, a semantic AI system like a RAG. Maybe it's going on to the internet. Maybe it's studying a PDF file. And so it might be using tools. It might be using a calculator. And it might be using a generative AI to generate charts and such. And it's taking the problem you gave it, breaking it down step by step, and it's iterating through all these different models. Well, in order to respond to a customer in the future, in order for AI to respond, it used to be ask a question, answer starts spewing out. In the future, you ask a question, a whole bunch of models are going to be working in the background. And so test time scaling, the amount of computation used for inferencing, is going to go through the roof. It's going to go through the roof because we want better and better answers. Well, to help the industry build agentic AI, our go-to-market is not direct to enterprise customers. Our go-to-market is we work with software developers in the IT ecosystem to integrate our technology to make possible new capabilities, just like we did with CUDA libraries. We now want to do that with AI libraries. And just as the computing model of the past has APIs that are doing computer graphics or doing linear algebra or doing fluid dynamics, in the future, on top of those acceleration libraries, CUDA acceleration libraries, we'll have AI libraries. We've created 3 things for helping the ecosystem build agentic AI. Nvidia NIMs, which are essentially AI microservices all packaged up. It takes all of this really complicated CUDA software, CUDA DNN, Cutlass, or TensorRT-LM, or Triton, or all of these different really complicated software, and the model itself, we package it up, we optimize it, we put it into a container, and you could take it wherever you like. And so we have models for vision, for understanding languages, for speech, for animation, for digital biology, and we have some new exciting models coming for physical AI. And these AI models run in every single cloud because NVIDIA's GPUs are now available in every single cloud. It's available in every single OEM. So you could literally take these models integrate it into your software packages, create AI agents that run on Cadence, or there might be ServiceNow agents, or they might be SAP agents, and they could deploy it to their customers and run it wherever the customers want to run the software. The next layer is what we call Nvidia Nemo. Nemo is essentially a digital employee onboarding and training evaluation system. In the future, these AI agents are essentially digital workforce that are working alongside your employees, doing things for you on your behalf. And so the way that you would bring these specialized agents these special agents into your company is to onboard them, just like you onboard an employee. And so we have different libraries that helps these AI agents be trained for the type of language in your company. Maybe the vocabulary is unique to your company, the business process is different, the way you work is different. So you would give them examples of what the work product should look like, and they would try to generate it, and you would give it feedback, and then you would evaluate them, so on and so forth. And so that, and you would guardrail them. You say, these are the things that you're not allowed to do. These are the things you're not allowed to say. And we even give them access to certain information. Okay, so that entire pipeline, digital employee pipeline, is called Nemo. In a lot of ways, the IT department of every company is going to be the HR department of AI agents in the future. Today, they manage and maintain a bunch of software from the IT industry. In the future, they'll maintain, nurture, onboard, and improve a whole bunch of digital agents and provision them to the companies to use. Okay, and so your IT department is going to become kind of like AI agent HR. And on top of that, we provide a whole bunch of blueprints that our ecosystem could take advantage of. All of this is completely open source, and so you could take it and modify the blueprints. We have blueprints for all kinds of different types of agents. Well, today we're also announcing that we're doing something that's really cool and I think really clever. We're announcing a whole family of models that are based off of Llama, the Nvidia Llama Nemotron language foundation models. Llama 3.1 is a complete phenomenon. The download of Llama 3.1 from Meta, 650,000 times, something like that. It has been derived and turned into other models, about 60,000 other different models. It is singularly the reason why just about every single enterprise and every single industry has been activated to start working on AI. Well, the thing that we did was we realized that the Llama models really could be better fine-tuned for enterprise use. And so we fine-tune them using our expertise and our capabilities, and we turn them into the Llama Nemotron suite of open models. There are small ones that interact in very, very fast response time, extremely small. They're what we call super Llama Nemotron supers. They're basically your mainstream versions of your models. Or your ultra model. The ultra model could be used to be a teacher model for a whole bunch of other models. It could be a reward model, evaluator, a judge for other models to create answers and decide whether it's a good answer or not, basically give feedback to other models. It could be distilled in a lot of different ways. Basically, a teacher model, a knowledge distillation model. Very large, very capable. And so all of this is now available online. Well, these models are incredible. It's number one in leaderboards for chat, leaderboard for instruction, leaderboard for retrieval. So the different types of functionalities necessary that are used in AI agents around the world, these are going to be incredible models for you. We're also working with the ecosystem. All of our NVIDIA AI technologies are integrated into the IT industry. We have great partners and really great work being done at ServiceNow, at SAP, at Siemens for industrial AI. Cadence is doing great work. Synopsys is doing great work. I'm really proud of the work that we do with Perplexity. As you know, they revolutionized search. Yeah, really fantastic stuff. Codium, every software engineer in the world. This is going to be the next giant AI application, next giant AI service period is software coding. 30 million software engineers around the world. Everybody is going to have a software assistant helping them code. If not, obviously you're going to be way less productive and create lesser good code. And so this is 30 million. There's 1 billion knowledge workers in the world. It is very, very clear AI agents is probably the next robotics industry and likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents.
AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at NVIDIA, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual Lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And Video Analytics AI agents, built on an NVIDIA Metropolis blueprint, including NVIDIA Cosmos Nematron vision language models, Llama Nematron LLMs, and NeMo Retriever. Metropolis agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, they monitor processes and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here for every organization.
Okay. That was the first pitch at a baseball game. That was not generated. I just felt that none of you were impressed.
The guy in the
Okay,
thing,
so AI,
the black guy, I was like, what?
Was created in the cloud
Like
and
AI.
for the cloud. AI is created in the cloud for the cloud. And for enjoying AI on phones, of course, it's perfect. Very, very soon, we're going to have a continuous AI that's going to be with you. And when you use those Meta glasses, you could, of course, point at something, look at something, and ask it, whatever information you want. And so AI is perfect in the cloud. It was created in the cloud, it's perfect in the cloud. However, we would love to be able to take that AI everywhere. I've mentioned already that you could take NVIDIA AI to any cloud, but you could also put it inside your company. But the thing that we want to do more than anything is put it on our PC as well. And so, as you know, Windows 95 revolutionized the computer industry. It made possible this new suite of multimedia services, and it changed the way that applications was created forever. Windows 95, this model of computing, of course, is not perfect for AI. And so the thing that we would like to do is we would like to have, in the future, your AI basically become your AI assistant. And instead of just the 3D APIs and the sound APIs and the video APIs, you would have generative APIs for 3D, and generative APIs for language, and generative AI for sound, and so on and so forth. And we need a system that makes that possible while leveraging the massive investment that's in the cloud. there's no way that the world can create yet another way of programming AI models. It's just not going to happen. And so if we could figure out a way to make Windows PC a world-class AI PC, it would be completely awesome. And it turns out the answer is Windows. It's Windows WSL2. Windows WSL2. Windows WSL2 basically is 2 operating systems within one. It works perfectly. It's developed for developers, and it's developed so that you can have access to bare metal. WSL2 has been optimized for cloud-native applications. It is optimized for, and very importantly, it's been optimized for CUDA. And so WSL2 supports CUDA perfectly out of the box. As a result, everything that I showed you with NVIDIA NIMs, NVIDIA NeMo, the blueprints that we develop that are going to be up in ai.nvidia.com, so long as the computer fits it, so long as you can fit that model, and we're going to have many models that fit, whether it's vision models or language models or speech models or these animation digital human models, all kinds of different types of models are going to be perfect for your PC, and you download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a blueprint we just made for you.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets, created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and NVIDIA NIM, an artist can quickly realize their vision.
NVIDIA AI for your PCs. Hundreds of millions of PCs in the world with Windows, and so we could get them ready for AI. OEMs, all the PC OEMs we work with, just basically all of the world's leading PC OEMs, are going to get their PCs ready for this stack. And so AI PCs are coming to a home near you. Linux is good. Okay, let's talk about physical AI. Speaking of Linux, let's talk about physical AI. So, physical AI. Imagine, whereas your large language model, you give it your context, your prompt on the left, and it generates tokens one at a time to produce the output. That's basically how it works. The amazing thing is this model in the middle is quite large, has billions of parameters. The context length is incredibly large because you might decide to load in a PDF. In my case, I might load in several PDFs before I ask it a question. Those PDFs are turned into tokens. The basic attention characteristic of a transformer has every single token find its relationship and relevance against every other token. So you could have hundreds of thousands of tokens, and the computational load increases quadratically, and it does this, all of the parameters, all of the input sequence, process it through every single layer of the transformer, and it produces one token. That's the reason why we needed Blackwell. And then the next token is produced when the current token is done. It puts the current token into the input sequence, and takes that whole thing and generates the next token. It does it one at a time. This is the transformer model. It's the reason why it is so incredibly effective, computationally demanding. What if instead of PDFs, it's your surrounding? And what if instead of the prompt, a question, it's a request? Go over there and pick up that, that box and bring it back. And instead of what is produced in tokens as text, it produces action tokens. Well, that I just described is a very sensible thing for the future of robotics. And the technology is right around the corner. But what we need to do is we need to create the effectively the world model of, as opposed to GPT, which is a language model. And this world model has to understand the language of the world. It has to understand physical dynamics, things like gravity and friction and inertia. It has to understand geometric and spatial relationships. It has to understand cause and effect. If you drop something, it falls to the ground. If you, poke at it, it tips over. It has to understand object permanence. If you roll a ball over the kitchen counter, when it goes off the other side, the ball didn't leave into another quantum universe. That's still there. And so all of these types of understanding is intuitive understanding that we know that most models today have a very hard time with. And so we would like to create a world, we need a world foundation model. Today we're announcing a very big thing. We're announcing NVIDIA Cosmos, a world foundation model that is designed, that was created to understand the physical world. And the only way for you to really understand this is to see it. Let's play it.
The next frontier of AI is physical AI. Model performance is directly related to data availability, but physical world data is costly to capture, curate, and label. NVIDIA Cosmos is a world foundation model development platform to advance physical AI. It includes auto-regressive world foundation models, diffusion-based world foundation models, advanced tokenizers, and an NVIDIA CUDA, an AI-accelerated data pipeline. Cosmos models ingest text, image, or video prompts and generate virtual world states as videos. Cosmos generations prioritize the unique requirements of AV and robotics use cases, like real-world environments, lighting, and object permanence. Developers use NVIDIA Omniverse to build physics-based, geospatially accurate scenarios, then output Omniverse renders into Cosmos, which generates photoreal, physically based synthetic data. Whether diverse objects or environments, conditions like weather or time of day, or edge case scenarios. Developers use Cosmos to generate worlds for reinforcement learning AI feedback to improve policy models, or to test and validate model performance, even across multi-sensor views. Cosmos can generate tokens in real time, bringing the power of foresight and multiverse simulation to AI models, generating every possible future to help the model select the right path.
They took our dude!
Working with the world's developer ecosystem, NVIDIA is helping advance the next wave of physical AI.
NVIDIA Cosmos. NVIDIA Cosmos. NVIDIA Cosmos, the world's first world foundation model. It is trained on 20 million hours of video. The 20 million hours of video focuses on physical dynamic things. So dynamic nature themes, humans walking, hands moving, manipulating things, things that are fast camera movements. It's really about teaching the AI, not about generating creative content, but teaching the AI to understand the physical world. And with this physical AI, There are many downstream things that we could do as a result. We could do synthetic data generation to train models. We could distill it and turn it into effectively the beginnings of a robotics model. You could have it generate multiple physically based, physically plausible scenarios of the future, basically do a Doctor Strange. You could, because this model understands the physical world, of course, you saw a whole bunch of images generated. This model understanding the physical world, it also could do, of course, captioning. And so it could take videos, caption it incredibly well, and that captioning and the video could be used to train large language models, multimodality large language models. And so you could use this technology to use this foundation model to train robots, as well as large language models. And so this is the Nvidia Cosmos. The platform has an autoregressive model for real-time applications, has diffusion model for very high-quality image generation. It's incredible tokenizer, basically learning the vocabulary of real world, and a data pipeline so that if you would like to take all of this and then train it on your own data, this data pipeline, because there's so much data involved, we've accelerated everything end-to-end for you. And so this is the world's first data processing pipeline that's CUDA accelerated as well as AI accelerated. All of this is part of the Cosmos platform. And today we're announcing that Cosmos is open licensed. It's open available on GitHub. We hope that this moment, and there's a small, medium, large for very fast models, mainstream models, and also teacher models, basically not knowledge transfer models. Cosmos World Foundation model being open, we really hope will do for the world of robotics and industrial AI what Llama 3 has done for enterprise AI. The magic happens when you connect Cosmos to Omniverse, and the reason fundamentally is this. Omniverse is a physics grounded, not physically grounded, but physics grounded. It's algorithmic physics, principled physics simulation grounded system. It's a simulator. When you connect that to Cosmos, it provides the grounding, the ground truth that can control and to condition the Osmos generation. As a result, what comes out of Osmos is grounded on truth. This is exactly the same idea as connecting a large language model to a RAG, to a retrieval augmented generation system. You want to ground the AI generation on ground truth. And so the combination of the two gives you a physically simulated, a physically grounded multiverse generator. And the application, the use cases are really quite exciting. And of course, for robotics, for industrial applications, it is very, very clear. This Cosmos plus Omniverse plus Cosmos represents the third computer that's necessary for building robotic systems. Every robotics company will ultimately have to build 3 computers. The robotic system could be a factory, the robotic system could be a car, it could be a robot. You need 3 fundamental computers. One computer, of course, to train the AI. We call it the DGX computer to train the AI. Another, of course, when you're done, to deploy the AI. We call that AGX. That's inside the car, in the robot, or in an AMR, or at the in a stadium, or whatever it is. These computers are at the edge and they're autonomous. But to connect the two, you need a digital twin. And this is all the simulations that you were seeing. The digital twin is where the AI that has been trained goes to practice, to be refined, to do its synthetic data generation, reinforcement learning, AI feedback, such and such. And so it's the digital twin of the AI. These 3 computers are going to be working interactively. NVIDIA's strategy for the industrial world, and we've been talking about this for some time, is this 3-computer system. Instead of a three-body problem, we have a 3-computer solution. And so it's the NVIDIA of robotics. So let me give you 3 examples. All right, so the first example is how we apply all of this to industrial digitalization. There are millions of factories, hundreds of thousands of warehouses. That's basically it's the backbone of a $50 trillion manufacturing industry. All of that has to become software defined. All of it has to have automation in the future. And all of it will be infused with robotics. Well, we're partnering with Kion, the world's leading warehouse automation solutions provider, and Accenture, the world's largest professional services provider, and they have a big focus in digital manufacturing. And we're working together to create something that's really special. And I'll show you that in a second. But our go-to-market is essentially the same as all of the other software platforms and all the technology platforms that we have through the developers and ecosystem partners. And we have just a growing number of ecosystem partners connecting to Omniverse. And the reason for that is very clear. Everybody wants to digitalize the future of industries. There's so much waste, so much opportunity for automation in that $50 trillion of the world's GDP. So let's take a look at that, this one example that we're doing with Kion and Accenture.
Kion, the supply chain solution company, Accenture, a global leader in professional services, and Nvidia are bringing physical AI to the $1 trillion warehouse and distribution center market. Managing high-performance warehouse logistics involves navigating a complex web of decisions influenced by constantly shifting variables. These include daily and seasonal demand changes, space constraints, workforce availability, and the integration of diverse robotic and automated systems. And predicting operational KPIs of a physical warehouse is nearly impossible today. To tackle these challenges, Kion is adopting Mega, an Nvidia Omniverse blueprint for building industrial digital twins to test and optimize robotic fleets. First, Kion's warehouse management solution assigns tasks to the industrial AI brains in the digital twin, such as moving a load from a buffer location to a shuttle storage solution. The robot's brains are in a simulation of a physical warehouse, digitalized into Omniverse using OpenUSD connectors to aggregate CAD, video and image to 3D, LiDAR to point cloud, and AI-generated data. The fleet of robots execute tasks by perceiving and reasoning about their Omniverse digital twin environment, planning their next motion.
I can translate this for you. They're just essentially taking your jobs. Basically, they are using LiDAR, which is basically like a light array, in order to get an idea, a layout of the land, and they use that to maneuver and move packages. And because of that, very few humans will be needed because most of it will be in AI. That's pretty much the translation of what they're trying to talk about.
Operational KPIs.
So the overall cost may have a higher upfront cost, but over the course of 10 years or 15 years, it'll make the money back tenfold.
Together with Nvidia, Kion and Accenture are reinventing industrial autonomy.
In the future, that's incredible. Everything is in simulation. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, autonomous vehicles. The AV revolution has arrived. After so many years, with Waymo's success and Tesla's success, it is very, very clear autonomous vehicles has finally arrived. Well, our offering to this industry is the three computers: the training systems to train the AIs, the simulation systems, and the synthetic data generation systems, Omniverse and now Cosmos, and also the computer that's inside the car. Each car company might work with us in a different way, use one or two or three of the computers. We're working with just about every major car company around the world: Waymo and Zoox and Tesla, of course, in their data center, BYD, the largest EV company in the world. JLR's got a really cool car coming. Mercedes has a fleet of cars coming with Nvidia starting this year, going to production. And I'm super, super pleased to announce that today, Toyota and Nvidia are going to partner together to create their next generation AVs. Just so many cool companies, Lucid and Rivian and Xiaomi and of course Volvo, just so many different companies. Wabi is building self-driving trucks. Aurora, we announced this week also that Aurora is going to use Nvidia to build self-driving trucks.
It's pronounced Acura.
Autonomous, 100 million cars built each year, a billion vehicles on the road all over the world, 1 trillion miles that are driven around the world each year. That's all going to be either highly autonomous or, fully autonomous coming up. And so this is going to be a very large industry. I predict that this will likely be the first multi-trillion-dollar robotics industry. This business for us, notice in just a few of these cars that are starting to ramp into the world, our business is already $4 billion, and this year probably on a run rate about $5 billion. So really significant business already. This is going to be very large. Well, today we're announcing that our next generation processor for the car, our next generation computer for the car, is called Thor. I have one right here. Hang on a second. Okay, this is Thor. This is Thor. This is a robotics computer. This is a robotics computer. It takes sensors and just a madness amount of sensor information, process it, umpteen cameras, high resolution, radars, lidars, they're all coming into this chip. And this chip has to process all that sensor, turn them into tokens, put them into a transformer, and predict the next path. And this AV computer is now in full production. Thor is 20 times the processing capability of our last generation Orin, which is really the standard of autonomous vehicles today. And so this is just really quite incredible. Thor is in full production. This robotics processor, by the way, also goes into a full robot. And so it could be an AMR, it could be a humanoid robot, it could be the brain, it could be the manipulator. This processor basically is a universal robotics computer. The second part of our drive system that I'm incredibly proud of is the dedication to safety. Drive OS, I'm pleased to announce, is now the first software-defined programmable AI computer that has been certified up to ASIL D, which is the highest standard of functional safety for automobiles. The only and the highest. And so I'm really, really proud of this. ASIL D, ISO 26262. It is the work of some 15,000 engineering years. This is just extraordinary work. And as a result of that, CUDA is now a functional, safe computer. And so if you're building a robot, NVIDIA CUDA, yep.
Clap hands.
Okay, so now I told you I was going to show you what would we use Omniverse and Cosmos to do in the context of self-driving cars. And today, instead of showing you a whole bunch of videos of cars driving on the road, I'll show you some of that too. But I want to show you how we use the car to reconstruct digital twins automatically using AI and use that capability to train future AI models. Okay, let's play it.
The autonomous vehicle revolution is here. Building autonomous vehicles, like all robots, requires 3 computers. NVIDIA DGX to train AI models, Omniverse to test drive and generate synthetic data, and Drive AGX, a supercomputer in the car. Building safe autonomous vehicles means addressing edge scenarios, but real-world data is limited, so synthetic data is essential for training. The Autonomous Vehicle Data Factory, powered by NVIDIA Omniverse, AI models, and Cosmos, generates synthetic driving scenarios that enhance training data by orders of magnitude. First, OmniMap fuses map and geospatial data to construct drivable 3D environments. Driving scenario variations can be generated from replayed drive logs or AI traffic generators. Next, a neural reconstruction engine uses autonomous vehicle sensor logs to create high-fidelity 4D simulation environments. It replays previous drives in 3D and generates scenario variations to amplify training data. Finally, Edify 3DS automatically searches through existing asset libraries or generates new assets to create sim-ready scenes. The Omniverse scenarios are used to condition Cosmos to generate massive amounts of photorealistic data, reducing the sim-to-real gap. And with text prompts, generate near infinite variations of the driving scenario. With Cosmos Nemotron Video Search, the massively scaled synthetic dataset, combined with recorded drives, can be curated to train models. Nvidia's AI Data Factory scales hundreds of drives into billions of effective miles, setting the standard for safe and advanced autonomous driving.
Isn't that incredible? We take thousands of drives and turn them into billions of miles. We are going to have mountains of training data for autonomous vehicles. Of course, we still need actual cars on the road. Of course, we will continuously collect data for as long as we shall live. However, synthetic data generation using this multiverse, physically based, physically grounded capability so that we generate data for training AIs that are physically grounded and accurate or plausible so that we could have an enormous amount of data to train with. The AV industry is here. This is an incredibly exciting time, super excited about the next several years. I think you're going to see, just as computer graphics was revolutionized such incredible pace, you're going to see the pace of AV development increasing tremendously over the next several years. I think the next part is robotics. So humanoid robots.
Robot, let's go.
My friends. The ChatGPT moment for general robotics is just around the corner.
I be running.
And in fact, all of the enabling technologies that I've been talking about is
be like, oh, time to go.
Going to make it possible for us in the next several years to see very rapid breakthroughs, surprising breakthroughs in general robotics. Now, the reason why general robotics is so important is whereas robots with tracks and wheels require special environments to accommodate them, there are three robots in the world that we can make that require no green fields. Brownfield adaptation is perfect. If we could possibly build these amazing robots, we could deploy them in exactly the world that we've built for ourselves. These three robots are, one, agentic robots and agentic AI, because they're information workers. So long as they could accommodate the computers that we have in our offices, it's going to be great. Number two, self-driving cars. And the reason for that is we spent 100+ years building roads and cities. And then number three, humanoid robots. If we have the technology to solve these three, this will be the largest technology industry the world's ever seen. And so we think that the robotics era is just around the corner. The critical capability is how to train these robots. In the case of humanoid robots, the imitation information is rather hard to collect. And the reason for that is, in the case of car, you just drive it. We're driving cars all the time. In the case of these humanoid robots, the imitation information, the human demonstration is rather laborious to do. And so we need to come up with a clever way to take hundreds of demonstrations, thousands of human demonstrations, and somehow use artificial intelligence and Omniverse to synthetically generate millions of synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. Nvidia Isaac GR00T helps tackle these challenges, providing humanoid robot developers with 4 things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The Nvidia Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large data sets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos Multiverse Simulation Engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by Nvidia Isaac GR00T.
We're going to have mountains of data to train robots with. Nvidia Isaac GR00T. Nvidia Isaac GR00T. This is our platform to provide technology elements to the robotics industry to accelerate the development of general robotics. And, well, I have one more thing that I want to show you. None of this would be possible if not for this incredible project that we started about a decade ago. Inside the company was called Project Digits, Deep Learning GPU Intelligence Training System. Digits. Well, before we launched it, I shrunk it to DGX and to harmonize it with RTX, AGX, OVX, and all of the other X's that we have in the company. And it really revolutionized, DGX1 really revolutionized, where's DGX1? DGX1 revolutionized artificial intelligence. The reason why we built it was because we wanted to make it possible for researchers and startups to have an out-of-the-box AI supercomputer. Imagine the way supercomputers were built in the past. You really have to build your own facility, and you have to go build your own infrastructure and really engineer it into existence. And so we created a supercomputer for AI development for researchers and startups that comes literally one out of the box. I delivered the first one to a startup company in 2016 called OpenAI, and Elon was there, and Ilya Sutskever was there, and many of the NVIDIA engineers were there, and we celebrated the arrival of DGX1, and obviously it revolutionized artificial intelligence and computing. But now artificial intelligence is everywhere. It's not just in researchers and startup labs. You know, we want artificial intelligence, as I mentioned in the beginning of our talk. This is now the new way of doing computing. This is the new way of doing software. every software engineer, every creative artist, everybody who uses computers today as a tool will need an AI supercomputer. And so I just wish that DGX-1 was smaller. And, you know, you know, imagine, ladies and gentlemen, this is NVIDIA's latest AI supercomputer. And it's finally called Project Digits right now. And if you have a good name for it, reach out to us. Here's the amazing thing. This is an AI supercomputer. It runs the entire NVIDIA AI stack. All of NVIDIA software runs on this. DGX Cloud runs on this. This sits, well, somewhere, and it's wireless or, you know, connected to your computer. It's even a workstation if you like it to be. And you could access it, you could reach it like a cloud supercomputer, and NVIDIA's AI works on it. And it's based on a super secret chip that we've been working on called GB110, the smallest Grace Blackwell that we make. And I have, well, you know what? Let's show everybody inside. It's just so cute. And this is the chip that's inside. It is in production. This top secret chip we did in collaboration. The CPU, the Grace CPU, is built for NVIDIA in collaboration with MediaTek. They're the world's leading SoC company, and they worked with us to build this CPU SoC, and connect it with chip-to-chip NVLink to the Blackwell GPU. And this little thing here is in full production. We're expecting this computer to be available around May timeframe. And so it's coming at you. It's just incredible what we could do. And it's just, I think you really...
Really?
I was trying to figure out, do I need more hands or more pockets? All right, so imagine this is what it looks like. You know, who doesn't want one of those? And if you use PC, Mac, you know, anything, because you know, it's a cloud platform. It's a cloud computing platform that sits on your desk. You could also use it as a Linux workstation if you like. If you would like to have double digits, this is what it looks like. You know, and you connect it together with ConnectX, and it has nickel, GPU Direct, all of that out of the box. It's like a supercomputer. Our entire supercomputing stack is available. And so, NVIDIA Project Digits. Okay. Well, let me tell you what I told you. I told you that we are in production with 3 new Blackwells. Not only is the Grace Blackwell supercomputers, NVLink 72s, in production all over the world, we now have 3 new Blackwell systems in production. One amazing AI foundational world foundation model, the world's first physical AI foundation model. It's open, available to activate the world's industries of robotics and such, and three robots. We're working on agentic AI, humanoid robots, and self-driving cars. It's been an incredible year. I want to thank all of you for your partnership. Thank all of you for coming. I made you a short video to reflect on last year and look forward to the next year. Play, please. Have a great CES, everybody. Happy New Year. Thank you.
Okay, there's quite a bit to talk about, but let me see if I can get back to when we were actually talking about the graphics cards. There's not a whole lot to talk about when it comes to literally everything else, but let me see if I can find it here. Maybe I can just do it directly here. Let's see. One second here. Let me see. Okay. Oh, he actually did talk about, okay, I fell asleep, clearly. Oh, no. I didn't fall asleep on this. This is where he was actually talking about the different graphics cards and how they changed and revolutionized CUDA. And then he brought out the, oh no, I take that back. Maybe he did. Okay, I clearly missed something. I must have fell asleep. Hold on.
6 years later or so, 2012, 2018, something happened that was pretty incredible. That creates and optimizes neural networks, that processes on GPUs, and creates artificial intelligence. Every single layer of the technology stack has been completely changed. An incredible transformation in just 12 years. Well, we can now understand information of just about any modality. Surely you've seen text and images and sounds and things like that. But not only can we understand those, we can understand amino acids, we can understand physics. We understand them, we can translate them, and generate them. The applications are just completely endless. In fact, almost any AI application that you see.
There's a part of this that was getting me. So let me turn this down a tad bit. Because I didn't, okay, well, we'll see. All right, check it out. So it actually does say DLSS 4.0 full RT on. I didn't remember him mentioning DLSS at all. So that's why I was just trying to go back over it just to make sure I didn't forget or miss it or something. But yeah, that's why it threw me off, because I saw this out the corner of my eyes, but I didn't know that he actually said DLSS. Like throughout this entire presentation, he never mentioned DLSS 4.0, but it does show that DLSS 4.0 is on this RTX card. Now, he doesn't say specifically whether or not it's associated with the 5090, 5080, and 5070, but you can probably draw that conclusion just from looking at this one picture. So that definitely helps, you know, just as far as where he was talking about when he said the 5090 is 2 times faster than the 4090, and the 4090 is on par with the 5070, which was a little odd. I was like, okay, like, come on now. Generally, the 4090 is going to be equivalent to the 80 series of the following tier, but for it to be equivalent to a 5070, then there must be some type of tracing on, some type of DLSS on that is more superior to that of the previous model.
Here it is. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast.
All right, so first off, while he's showing that off, it's a 2-slot card. So he said that this was the RTX 5090. He did not say that was the 5080. He said that that was the 5090. So the 5090 default Nvidia card is 2-slot, which is really good. Now, whether or not the OEM models, the manufacturer models, like once it gets to like other manufacturers like Asus and so on and so forth, will they also be 2-slot? I seriously doubt it. They're probably going to be 3-slot. But at the same time, I would love to get a 2-slot. I have been craving for a 2-slot 2-slot graphics card since forever. I love 2-slots. Like I had the 1080, the 1080 Ti Mini, and then I had the 3090 2-slotter. And so now I would love, like the 4090 I have is like one of the biggest ones. I have the Gigabyte 4090, and it's like 3.5, 4.5, 5.5 slots, like it's a big boy. So the fact that he can actually hold that without breaking his thumb is a pretty good sign that that's a pretty thin card. And plus you can look at it from the side there. One thing that I would like it to have is USB-C. It would be nice that if you have like a camera or something along those lines, that it can actually also take a USB-C as an input in order to basically put that camera on, like set it up as a camera app or use it as a camera in your video encoding. So basically some type of encoding that allows you to hook up your camera directly into it. So take an actual input. That would be really cool. So like have an input and like 4 outputs, because sometimes people don't really use like all ports. So maybe have 1 input and maybe 4 outputs would be great. But you know, it is what it is. I'm not picky. I'm just happy that it's actually a 2-slotter, because you just don't get that these days anymore, especially on the higher tier models. Now, one of the things that he did talk about was the price point. Now he was talking about how the 4090 was $1599. This isn't true. I don't know which 4090 you got. I'm joking. So the 4090, when it first came out, it really was $1599. The problem was it got scalped almost instantly. I ended up getting mine by waiting in line for like 3 hours at Micro Center, and I got mine, which was the gigabyte version. And the gigabyte version actually was, I think it was like $17.99 or $16.99. It was somewhere in that area, and it's one of the bigger cards that they had. So 9 times out of 10, if you're looking for the 5090 here, because he said it was 2 times faster, please take that with a grain of salt. He's talking about with DLSS 4.0, because he actually showed it on a picture. Even though he didn't say DLSS 4.0, you can clearly see that DLSS 4.0 is a part of this from the picture that we just looked at. It's using DLSS 4.0 and is using that to make that kind of a suggestion. So by saying the RTX 5070 is equivalent to the 4090, obviously that's not going to be entirely true. That is with DLSS 4.0 turned on. So please bear that in mind. Whereas the 4090 performance is only DLSS 3.0. So basically it's doing more frame generation on the newer tier series than it was on the previous tier model. Now it also, you know, pokes fun at everybody that bought a 4090. He was like, oh yeah, you remember when you bought the 4090? Well, the 5070 is equivalent to a 4090, so sucks to be you. Yeah, so please bear that in mind. I mean, there's no probably. It's a pretty good shot that he's talking about DLSS 4.0, and that's the reason why these two are equivalent. Otherwise, it would not be the case. And so the RTX 5070 he's putting at $549, which is very impressive. And we'll just pause it here because I know this screen wasn't on there for very long. But the 5070 with 1,000 AI teraflops or tops is $549. The 5070 Ti, which is $749, comes with 1,400 AI teraflops or tops. I'm just gonna go with tops because that's what it says. And then the RTX 5080 is $989. I'm liking that price for the 5080. And it has 1,800 AI tops, and then the 5090 at 3,400 AI tops for $1,999. So it's $500 or $400 more than what the 4090 was when it first came out. But please bear in mind, all of these sold out almost immediately, like almost immediately. And so if you want your hands on a 2-slot card, you're gonna have to like get in there on it. You know what I mean? But for a 5080 to be, you know, 5080 is probably where that sweet spot is, because most people, like if they're really kind of going towards the higher end of gaming and they're looking for the 50 series card, that $999 for the 5080 looks absolutely amazing, because you can get 2 of these for the price of one 5090. That is something, because, okay, even when the 4080 came out, so if we look at the 4080, let me pull it up here. So RTX 4080 launch price. All right. Okay, so it was $1199, right? So it was $1199, and then the 4090 was $1599. Okay, well that's only a $400 price point difference, or a price point difference between them. But the 4090 was far superior in terms of performance than the 4080. But in this case here, we're talking about the 5080 and 5090. I would buy 2 5080s just from what it's telling me here. Now, I get that it's a higher amount of teraflops, which means that if it's running DLSS 4.0, it will be far superior. I get that, but I would rather have 2 5080s. I think that maybe the 5090 price point is a little bit too high. Now, if it had gone to maybe $1699, then I get you. But at $1999, you literally are telling us that one 5090 is equivalent to 2 of these 5080s, and I don't think that's the case. I think that you will be a lot happier with the 5080 simply because the 5090 price point is just unreachable. Now, what's going to happen is that the 5080 is going to get scalped. And so it's going to force you into the 5090, even though you don't want to be there. But yeah, if I had to look at these and say, just from what he's showing and the fact that he's talking about DLSS 4.0, I would say the 5080 would probably be your best bet because, okay, look at it like this. The 4090, right? If we kind of go back to the 4090, it pretty much gave you everything that you needed, right? It gave you all you needed in 4K, all you needed in 2K, and obviously all you needed at 1080p. So if this guy gives you everything that you need just from talking about the 4090, then the 5080 will do the exact same thing, right? Now, it will do the exact same thing with DLSS 4.0, which means that 9 times out of 10, if you have a 4K 240 hertz monitor or 4K 165, 4K 144, it's going to let you hit that in just about every other game or just about every game that you play because you're running DLSS 4.0. Does that make sense? So because the fact that you're already running it, the 5090 is supposed to be more than that, but there isn't any monitor that needs that. You see what I'm saying? So once you hit that 4K 144, you really don't need much more than that. As long as you can get 4K 144, 4K 165 consistently, then there's no need to go higher. So if the 5080 more than likely can give that to you because the 4090 can almost give that to you. The 4090 can almost hit that now. You know what I mean? It can almost hit that with 80%. I would say 80% of games, it can give you that. And so when you look at it, the 5090 just seems unfeasible for most people because there's just no point. Okay, so, you know, if you can get 4K 360 frames per second, who cares? You're never gonna get, like, bro, you're never going to need that. So your eyes are not gonna get any further than like 165 hertz. You might be able to tell the difference between a 165 and a 240, but there's just no point to it, right? Because that 4090 just about gave you everything that you needed. So we're only talking on the high end. And even when I'm looking at the high end, I would say a 5080 is kind of where you need to cut it off at because there's just no point in paying double for that 5090 when you only have 4K 240 to work with, when you only have 4K 165 to work with, when you only have 4K 120, when you only have 4K 144, when you only have that frame rate to work with. And true, you know, years from now, new monitors may come out that give you 4K 360, but I would still say you're not going to notice that difference, right? If you're already sitting at 4K 144 or 4K 165, you're not going to notice a difference from a 240 to a 360 and it's 4K 360 frames per second. Like, you're not going to notice that, bro. Like, you're not a dog. It's not going to do you any good. So I think they may have priced themselves out of the market, but they may be saved because scalpers may save them because there's literally no point in having that 5090. You'd be better off having that 5080. And if you need another one, buy two. You know what I mean? But of course you can't SLI anymore, but at the same time, it still makes more sense to have this. And even when he's talking about his comparison, calling the 4090 equivalent to the 5070 because the 4090 has DLSS 3 and the 5070 has DLSS 4, he didn't say that specifically, but it's very obvious from the picture that he was using DLSS 4. It's still not a very good comparison because as soon as you turn off DLSS, the 4090 will smoke it, right? So I would say the 5080 will kind of be your sweet spot. Basically, I would call the 5080 a cheaper 4090 with DLSS 4.0. That's what I would call it. I would say the 5080 is going to be your best bet if you're looking for a higher end graphics card and just throw the 5090 out of the water and just don't even worry about it. So because of that, this isn't a hard conclusion to make, which means that 9 times out of 10, this thing is going to get scalped to high heaven and you're not going to see it. So I would say whenever it comes out, whenever it launches, get it first. Go for the 5080 because the 5090's price point just doesn't make sense for what's available on the market. Whew, okay. And so, yeah, let me just go back to, oh, sorry, right here. So yeah, it's not available or it's not ideal. That $19.99 is just a bit too much. And yeah, I think that's gonna kind of do it for me on where I am here on this. But I mean, hey, they just brought it out. I'm excited. It comes out in January, doesn't say exactly when. More than likely, a 5090 will come out before the 5080 because the 5080 just looks like a beast at this point. But yeah, that's going to do it for today's episode. Thank you guys so much for watching. And if you like this video, go to like button. If you really like it, go and subscribe. I love you either way. Take care. All the best and bye. I will see you next time. Peace.